Hello, welcome again to the lecture series on control systems engineering. So far, how to draw an Nyquist plot manually and find the system stability that we discussed. Now, in this session, let us discuss how Nyquist plots can be drawn using Matlab. Also, we can find the relative stability of the system. Right. Now you want to draw the Nyquist plot using Matlab. It's very simple. So transfer function is given. Numerator is 2, 5, 1. Denominator is 1, 2, 3. Say TF transfer function H. Use the command Nyquist H of H. So it will draw the plot. So simple it is. Okay. That's how we can use Matlab and you can draw the Nyquist plot. Now relative stability on Nyquist plot. So the thing is, you know that suppose this is sigma, this is j omega. Suppose there is a value here, root there, this is the response. This value is -2, then the response is y is equal to e to the power of -2t. Then if I plot the response when t is equal to 0, y value will be 1, as t increases, it will decay down. By chance there is a pole here, let us say at -4, then the response will be y equal to e to the power of -4t. Then the response will decay much faster. Correct now. Relative stability of the system is the property measured by the relative settling time of each of the root or pair of roots. A system with a shorter settling time is considered more relatively stable. Correct? We would like to determine similar measure of relative stability useful for frequency domain analysis. Okay. Again, these root locations, again, probably you have seen that. So here basically the time constant value what I am talking about. In this case time constant is t equal to 1 by 2, 0.5. So 0.5 means 4 time constant, the settling time is 2 seconds. In this case time constant is 1 by 4 and settling time 4 time constants means it's only 1 second. So as the root move like this, they settle down very fast. So also complex roots. This is how we say the relative stability. What is that we do here? Now here you take this. This is the Nyquist plot. REGH, IMGH you call it. Don't worry, even I have taken plot from different sources. I have not drawn on my own. That's why it happens. So I have drawn polar plot for a given transfer function for k1, k2, k3 like this. So you take any one polar plot like this, any one polar plot. Okay, the point at which it crosses -180 degree. This I call it as phase crossover, and the corresponding frequency is phase crossover frequency. Then you draw a circle of unit radius, Then it will cut here and that point origin you draw, join this point I call it as gain crossover, magnitude crossover or gain crossover. The corresponding frequency is gain crossover frequency. Now let us look at, you measure this value, measure this magnitude value. 1 by modulus of that value you substitute here, you call it as gain margin. It gives an idea. See, you know that. Suppose if you take this polar plot, okay, you complete the Nyquist plot if you want, then there is -1 plus J0 is here. It is encircling. It is an unstable case. This is a stable case. How far it is from becoming unstable is the question. So this value, you take reciprocal of that value, we call it as gain margin. So if you take this plot, if you measure this value is smaller. 1 by smaller value is what? Larger value. So larger the gain margin, it is far away from this. Correct? Suppose I get 0.01, then 1 by 0.01, 100. So larger the gain margin, then it is far away from that -1 plus J0. Okay. Same. Then whatever angle you measure here, this is what you call it as phase margin, corresponding phase margin. So we call it as a positive gain margin, positive phase margin. Suppose you get here this gain margin, you call it as negative gain margin and negative phase margin. Okay. So this is what? So relative stability. So gain margin is very, very small. It is about to become unstable. Phase margin is negative. It's about to become unstable, like approaching more than -180 degree, then it is, yes, unstable. So for an open loop stable system to become closed loop stable system, the magnitude at phase crossover frequency should be less than 1. That's what the gain margin is. Or open loop system to stable to become closed loop stable system, the phase angle at magnitude crossover frequency should be less than -180. That's the meaning of that. See here, I have indicated stable, it is unstable. Correct? This is -1 plus J0 point is here. And if you take this value, right here I should have taken, correct. Reciprocal of that will give you gain margin. If you take this one, reciprocal of that will be gain margin. This is more stable than this, and this is unstable. So gain margin is what is happening, reciprocal of that value. So smaller the value, gain margin is more. Okay. Okay. So that's what all these things are. You can also, using Matlab, you can find gain margin and phase margin. You can see this is the given transfer function. Anyway, it's a comment. It is not a executable statement. Here num is 0.5, din is 1 to 1.5. System is transfer function num by denominator. Okay, you got this transfer function. Magnitude, phase angle, and the correct frequency, Bode cis. So from Bode it will calculate magnitude and phase angle. Correct. Then gain margin, calculate gain margin, phase margin. I think gain crossover frequency, phase crossover frequency. So from this, correct. Okay, these functions will do that. Then Nyquist cis, call this function. Nyquist cis, call that function. After that, gain margin. Okay, you calculate the gain margin. After that, it will output the gain margin and also label it. Okay, phase margin, it will also indicate and label it. So we are using Bode function to calculate the gain margin, phase margin, then we are transferring it to the Nyquist. For the Nyquist transfer function, we calculate this. Okay, So you can find the gain margin, phase margin and all that. This is the gain margin. This is a circle of unit radius. This is the Nyquist plot. Okay, then this is the phase margin. Okay, that's how we can find the system stability and relative stability in Nyquist plots. Okay, I think in a simple way, probably I have taught all this. I think it is easy for you to pick up. So with this, we will end the discussion on Nyquist plots. Thank you very much.